Hello everyone, this is Ashish and this is my fourth session of Blackbook Organic Chemistry problem discussion. In last three sessions, we have discussed three unique problems from Blackbook, and in today's session, I am here with a fourth unique problem from the Blackbook, and the fourth problem is this one. And in the fourth problem, what we have given organic compound M has the following data. And if I write here organic compound M, which is having following data, first data is molecular weight is 149. Okay, we'll mention here molecular weight is 149. It contains only three elements. The meaning is the compound basically consists of three different elements. Three different elements may be like a carbon, hydrogen and oxygen, or carbon, hydrogen or sulfur, like so three different elements, right? So I am writing here three different elements. Next point, it can rotate plane polarized light, means compound must have some chirality, right? Compound must have chirality, then only it can rotate plane polarized light. Third hint, the third data is M on oxidation with hot alkaline KMNO4, means I'm writing here hot alkaline KMNO4 produces benzoic acid. This is a big clue, benzoic acid. By this data, we got one idea that definitely the compound M is having benzene ring, minimum one alpha carbon with minimum one alpha hydrogen, then only by oxidation of KMNO4 will get benzoic acid. This is the mandatory condition, what minimum condition we need. Benzene ring, one directly attached carbon, alpha carbon with minimum one hydrogen. Without hydrogen, we won't get benzoic acid in this case, right? Okay. So fourth hint is M can be prepared by treating carbonyl compound with methylamine followed by NaBH4. Okay, carbonyl compound with methylamine, NH2 methyl. This is basically NH2Z reaction. And if I directly solve this, then simply remove H2O molecule from these two reactants, and we get additional this addition product N methyl, like this. We are getting this amine basically. Amine on reduction with NaBH4 will get amine, N-methyl amine basically. Now one more hint we got, the compound is having NHCH3. Now you simply check how many carbon are there with this data. 6 carbon in benzene, 7th carbon alpha, 8th carbon in this methyl amine, means compound is having right now 8 carbon with atomic mass 12, it means 96. How many hydrogens? 5 hydrogen, 1 alpha hydrogen, 6, 1 7 with nitrogen, 3 with hydrogen, means 10 hydrogen with atomic mass 1, means 10, and 1 nitrogen means atomic mass is 14. So what I am getting here is 14, right? Now please add this: 6 4 10 0 1 9 1 10 1 11 12 120 mass we got, right, by these four clues. Now 29 left over out of 149, 29 left over. From 29, the easiest way, it may be like 2 carbon with mass 12, and for example 5 hydrogen with mass 1, 29 I can manage. Like this is the easiest way. Okay, leftover part is 29, so 2 carbon with mass 12 and 5 hydrogen with mass 1, we can manage this 29. Okay, we'll try with this data. Benzene ring, right, that is mandatory here. How many overall carbon other than this N-methyl amine? How many overall carbon other than benzene ring and N-methyl amine? 1 and 2 here, 3. So for 3 carbon I can manage one propyl part. Propyl, or propyl that chain isomeric condition is isopropyl. So I can manage with these two structures. Now n-methylamine, I need to keep this n-methylamine in these two structure in such a manner that compound must have a chirality, right? So okay, we'll try to keep this n-methylamine here. First, n-methylamine. Okay, here we have chiral center. Second, here n-methylamine. Yes, we have chiral center here. Third is this one. N-methylamine. We may get chiral center only this nitrogen, but nitrogen due to flipping it will have that racemic mixture condition, so I should not count this picture. Only these two pictures are considerable in n-propyl chain. For isopropyl chain, now listen carefully, for isopropyl chain, keep NH methyl here, you will get chiral center, right? That is okay, it's correct only. And suppose if you keep that n-methylamine here, in that case chirality lost, as well as there is no hydrogen. How you get a benzoic acid with KMnO4? So this is again a wrong picture. Finally we are getting these three structures of compound M, and now we can prove like first carbonyl compound that should be like this, and the second carbonyl compound that should be like this, and the third carbonyl compound that should be like this. And when these three compound react with NH2 methyl and followed by NaBH4, right, in all three in the same manner, you will get these three products. First, this one is first, this one is second, this one is third. So these three are the compound M. I think everyone got this problem. This problem is very good because in those four clues, we need to get the idea how to write the structure of compound M. So that type of problem when comes in exam, na, your raw brain is actually required. How much problem you have solved previously, right? And how much data you have stored in your mind, that all things like not required. Your real brain is actually required in such problems. You see in this problem, just basic things we have actually used in the problem, just basic concept we have used. There's no complexity, no exception, nothing we have used. We have used all basic concepts only. So just by clubbing those basic concepts, now we are getting the final answer, right? So I think everyone got this problem. In next video we will discuss the fifth unique problem from Blackbook. Thank you very much. Thank you.